Good morning, students. Welcome to today's class. Today we shall continue chapter 1, but the topic is fuels. The objectives are at the end of this presentation, you will be able to name the fuel coal, natural gas, and petroleum. You will be able to name methane as the main constituent of natural gas. You will be able to describe petroleum as a mixture of hydrocarbons and its separation into useful fractions by fractional distillation, and you will be able to name the uses of the fractions, and last you will be able to understand cracking of the long hydrocarbons. First, let us define or know the meaning of fuel. What is fuel? Fuel means any substance which provides energy. Then what are fossil fuels? Fossil fuels are petroleum, coal, and natural gas. Why they are called fossil fuels? Because they are the remains of plants and animals that lived millions of years ago. So these are all the three main fossil fuels present on the earth. We shall learn the very important fossil fuel, which is petroleum. Petroleum formed from the remains of dead organisms that fell to the ocean floor and were buried under thick sediment. High pressures slowly converted them to petroleum over millions of years. What is in petroleum? Petroleum is a smelly mixture of hundreds of different compounds. They are organic compounds, which means they contain carbon and usually hydrogen. So they are hydrocarbons. In fact, most are hydrocarbons. They contain only carbon and hydrogen. Refining a petroleum, which means separating useful compounds from a big mixture of hydrocarbon by fractional distillation, which is shown in the right hand side. In a refinery, the fractional distillation is carried out in a tower that is kept very hot at the base and cooler towards the top. Petroleum is pumped in at the base. The compounds start to boil off. Those with the smallest molecules boil off first and rise to the top of the tower. Others rise only part of the way depending on their boiling points and then condense. Thus, different fractional are collected. Now, let us see the properties of molecules within a fraction. First is the refinery gas, because the number of carbon atoms is very small, that is from C1 to C4, and the uses are bottled gases for cooking and heating. And the second is the gasoline, that is petroleum or petrol, and the number of carbon atom is from C5 to C6. It is used for fuel for cars. And third one is the naphtha, C6 to C10. It is not directly useful, but it is used as a starting point for many chemicals or making plastics by cracking. Paraffin, kerosene, the number of carbon atoms are from C10 to C15, is used for fuel for aircraft, oil stoves and lamps. Next is the diesel oil. The number of carbon atoms is from C15 to C20. It is used for fuel for diesel engine. Then fuel oil. The number of carbon atoms is from C20 to C30. Uses are fuel for power stations, ships and for home heating systems. Then lubricating fraction. The number of atoms, carbon atoms, are C30 to C50. Uses are oil for car engine and machinery, waxes and polishes. Last one is the bitumen, C50 upwards. The number of carbon atoms here is very big chain. Uses for road surfaces and rooftops. And the right hand side, the arrow mark shows the boiling point and viscosity increases as you go down the table. The next very important topic is cracking. What do you mean by cracking hydrocarbons? That is breaking long molecular chains of hydrocarbons into smaller ones. How it is done? It is done by thermal decomposition. So, cracking is an example of thermal decomposition. Thermal decomposition means by breaking the higher molecules by applying heat. Why is it done? Is it done because smaller chains have more demand and more useful? Example, petrol than butane. So the number of carbon atoms in petrol is lesser than butane, and the petrol is more useful than butane. So we break the larger chain into smaller one. That is done by cracking. So the smaller alkenes can be made into plastic furniture by a process known as polymerization. Condition for cracking are: in catalytic cracking, we use heat and a catalyst. The catalyst speeds up the reaction, but there is no change in the reaction. And in steam cracking, we use heat and steam. Look into the diagram on the right hand side. First diagram, the large hydrocarbon molecule, that is alkene, diesel, cracked by applying heat. So heat acts as a catalyst into smaller alkane and even small alkene, that is propene and ethane. And the below one also, the longer hydrocarbons is cracked down into smaller ones, and that smaller ones are very useful. Practice questions are given. Please kindly complete all your practice questions. Try to do as we learned cracking a larger hydrocarbon alkane into smaller alkane and alkene. Please see to the formula, general formula for alkane and alkene, and try to complete these questions. That's the end of today's class. Please do the practice questions in class notebooks. Stay home and be safe. Study well. Thank you, my dear children. Take care.